Hello everyone. Today's lesson we're going to learn about how to explain uh, how a mole is used indirectly to count the number of particles, and we're going to relate moles to everyday common counting units. We're going to convert between moles and particles or atoms and vice versa. Review term is molecule, which is atoms that is covalently bonded in one unit to form one unit. All right, so let's go ahead and get started. This is your focus, and I just want to go over it real quickly. And this is the daily things that we count: pair of shoes, dozen, ream of paper. So the first question is, what happens to the numerical value of the counting unit? Numerical value of the counting unit, this is what they're talking about, as the size of the item uh, that it counts decreases. So the volume, we go from, so this is the numerical and the volume. So let's focus on these two. The volume goes from 5 times 10 to the negative 5 to the negative 6. So as the volume decreases, the numerical value of the counting unit increases. Okay. How would you describe the numerical value of counting units that is needed to count atoms? So if we're dealing with atoms, it's a lot bigger than this. It's a lot more. So the number is huge, is enormous. So that's why we're going to be dealing with Avogadro's number to have it a more accurate system to count very small numbers. Oops, that didn't work. So counting a number of atoms, we're going to use something called moles, which is, it measures that, the amount of a substance. So moles is a system, is a base unit that measures the amount of a substance. And we call that Avogadro's number. So 1 mole has 6.02 times 10 to the 23rd atoms. Conversion factors, just like 1 dozen have 12 eggs, and we can convert between units. Or 1 meter has 100 centimeters, and we use that to convert between units. So let's go ahead and this is like a roadmap for things we're going to convert. Moles to grams or to atoms. So we're going to be focusing right now on the atoms. So from moles to atoms, we multiply by Avogadro's number. From atoms to moles, we divide by Avogadro's number. So write that down so when you're doing your practice. Now you have two methods of solving this. The first one, you can just start with what's given. So this one, conversion factor is 6.02 times 10 to the 23rd particles per 1 mole. So the problem is number of molecules. What are the number of molecules in 3.5 moles? So you always start with what's given, and you multiply by a conversion factor when you're going to moles, or when you're going to molecules or atoms. So in this case, you put 3.5 times 6. Now, in your scientific calculator, you have to find the EE or EXP. You press that, and you put 23 equals. And that if you don't get this number, then ask me in class, and then I'll go over it with you. Now, the second type of problem that we'll be dealing with is going from atoms to moles. So we're doing the opposite. We're using Avogadro's number still. So this one, we're going from 2.1 2.1 times 10 to the 24th molecules to moles. So when we're going from molecules or atoms to moles, we divide by Avogadro's number. Always start with what's given and then use Avogadro's numbers to get to the unknown, to solve for the unknown. So in this case, we put 2.11 EXP or EE 24 divided by 6.023 EXP 23 equals. The second method we'll be using is triangle method, where you put the conversion factor in this corner right here, and then the units, which is atoms per moles, atoms and moles, depending on which one is given and which one is they're asking for, we're going to either multiply or divide. So let me show you how to use this triangle. The first one is determine the number of atoms in 2.5 moles of zinc. So we start always the same, conversion factor in this corner right here, atoms on top, moles on the bottom. So what is given is moles, so it's going to be in this corner right here, 2.5, and they're asking for atoms. So they're next to each other, so you multiply. Okay, so you multiply 6.02 times 10 to the 23rd times 2.5. So 6.023 EXP 23 times 2.5 equals. And this is the number you should get. So when you're watching this video, go ahead and just double check what the answer. If you don't get it, ask me in class and we'll go over it again. Okay, given 3.5 moles. So this is a same type of problem where moles is going to go in this corner right here. They're next to each other, so you're going to multiply. So you start by 6.023 EXP or EE, if depending on the scientific calculators, this will be, we'll say EE or EXP, but we'll go over that in class. 23 times 3.25. And this is the answer you should get. Okay, let's do, this is also moles. So you put the number of moles right here next to each other, so you multiply. And these are the steps. You put 6.023 EXP 23 times 11.5. And this is the answer you should get. So you should be double checking with these to make sure you know how to follow the steps. Now we're going to do the opposite. We're going to start with 5. This is what the problem says. How many moles are in 5.75 times 10 to the 24th atoms of aluminum? So atoms of aluminum go on top, 5.75 times 10 to the 24th atoms of aluminum, and they're asking for moles. They're one on top of the other, we divide. So atoms to moles, we divide by Avogadro's number. And these are the steps. 5.75 EXP 24 divided by 6.023 EXP 23. And this is the answer you should get. If you don't get this answer, ask me in class and we'll go over it. Now, let's go back. I didn't write the problem for some reason. Now the second one, this is the, we're giving these 3.75 times 10 to the 24th molecules of CO2. Okay, so that goes on top. And they're asking for moles, so on top of each other we divide. These are the steps. 3.75 EXP 24 divided by 6.023 EXP 23, and this is the number you should get. I think I did one more. We started with 3.58 times 10 to the 23. Now formula units are the same also. This one ionic. And then we divide. So all of these we divide. 3.58 EXP 23 divided by 6.023 EXP 23, and this is the number you should get. think this is the last one. 2.5 times 10 to the 20th atoms of iron, and we want to convert that to moles, so we divide by Avogadro's number. And these are the steps. This is the answer you should get. Okay, I hope that helps. We'll see you guys next time. Thank you.